I would say normally, and I probably work on a slightly faster schedule than stuff, I get hours to make things before I have to print it out. A lot of times it'll be a last minute sort of issue, and so a lot of times I'll get an order at like noon, and I'll have to be in the machine by 6 o'clock that night. And so a lot of times I get like 6 hours. That's not a good example for what the field does. That's just my specific position, is that we basically get it at the very end when people are really stressed out and everything they've done has failed and they're like, we need this part tomorrow for a presentation. And so a lot of times I'll make it really quickly, but I know, like, for instance, on the one of the aerospace brackets that Boeing made took them 2 years of iterations to go through before they came up on the right application or on the right exact level. But that was a lot of testing, and it's an important bracket. If it breaks, people die. And so they went through the correct amount of testing and all the different what would it be called? All the right kind of checks and checks to make sure nothing fails in a really important area. But it basically just depends on the specific time and your access to printers. We have printers in my office, and so a lot of times I'll print stuff out overnight, like go home, like print it out at night, show up the next morning, test it, and then if it meets the criteria, I then send that file out to the customer, and they will print it on their own machine. Or a lot of times, if it doesn't meet that criteria, we'll then take it and tweak it, and then maybe we go through a week of iterative testing, where we'll change the settings on the machine. Like, we've refined this to be like it's the exact geometry that we want, and it seems to be working really well, but it's printing too slow. And so they want to print one of these, like when you array a whole set of these on a build plate, maybe you array 30 on a build plate, and it takes 30 hours to build, so you get 30 of the, or one per hour. Maybe they want one every 30 minutes. And so now I've got to fine-tune those settings down to a one every 30 minute kind of a build and time period, and then I'll send those settings off with the part to the final destination. So hopefully the people with the machine, whether that is the customer or the reseller or the service bureau, and they'll then take those parts and then run those particular settings. And so we do a lot of, what's the term? Basically refinement of processes. Like, say Invisalign will have already thought of their process, and they'll be like, this works really well for us, but it's just going too slow. And so we'll basically take those dental models and refine those dental models and the machine itself to the point where, not the machine, but refine the parameters to the point maybe you don't need the resolution that the machine is capable of. And so instead of printing your parts at 50 micron layers, maybe 150 micron layers is good enough, so that's a third of the time. And so that's a really useful thing, and it speeds up it speeds up the building time. But it depends on the application. Every application is so different that, for instance, medical devices, they have the general workflow down, like how you make a splint for some sort of knee surgery, or for drill guides for teeth. A lot of times, that workflow was refined by the FDA, different companies and the FDA years ago, and so now the people generating those dental guides, those drill guides, basically do 8 or 9 a day, and they literally print them out and send them to the doctor immediately. And so now that the workflow has been refined, it's not a lot of iterative testing and trying to figure things out, where the original, how do you design a drill guide for teeth, that may have taken a year to figure out how to do best. Your first attempt may have worked all right, but a couple of testing later, you're like, it builds up bacteria, or it always breaks when I do this one motion or something like that. And so over time, it's definitely it's every object is so different. A lot of these things sort of need to be refined for the specific, to get the best possible outcome. I would personally say a lot of every part kind of needs its own refinement. There's not a printer that I can think of where you would just be it'll just print everything really well and you don't have to do anything for it. A lot of them do print everything pretty well, but if you really want to fine tune it and you really want to get down to what can I get out of 3D printing, then it's worth spending the time and money to do some iterations on it to see if you can get the most optimal objects out of it. So I'm definitely sure there are ones with, what are they called? That plug into Solid Thinking, or SolidWorks. Right. I don't know of any off the top of my head. What I would do a lot of times when I get a Solid Thinking file, or not Solid Thinking, SolidWorks file, I leverage Rhino a lot. So I would bring it into Rhino and just apply that texture, and then bring it back into SolidWorks. And so a lot of times it's maybe just for a second, or maybe I go get like a trial version of Rhino, which is free, and Grasshopper's free. And it's all I know is there's a lot of softwares I know like 3 buttons in them, but those 3 buttons, and it's like a trial version of free software, but those 3 buttons are super useful for whatever my specific workflow is, that I don't need to learn the whole rest of it, like in ZBrush. Look at all those buttons up here. I've never used any of them, but I basically just do a small portion of that workflow, and ZBrush is a pretty cheap program. It's not a like $30,000, it's like $800. And I bought it years ago, and I've been using it ever since, and they were nice enough to keep giving me updates. But I know like a lot of things for very specific applications. Like I'll move it into Mesh Mixer, decimate it, and then move it out. And then that's just for 1 second it was in that program. But I'm trying to think of any. I can get you a list. I know Autodesk has a bunch of plugins for a lot of different softwares, like their T-Spline plugin goes into multiple different softwares. And I know their Dynamesh software, which is trying to compete with Grasshopper, is also, I think, plugs into multiple different ones. I know it plugs into Revit and Fusion 360 and a couple of their other CAD modelers. I've never tried to plug it into I don't know SolidWorks that well, and so that was why we have other SolidWorks people in our office that normally, if I need SolidWorks, they're the people who do it, and so we do. Let me try but that's one of the things we do is like kind of bounce around between different ones that are free just for like 2 commands. It's not always worth it to go and buy like a $30,000 software and be like, this only really does 4 things I wanted. Those 4 things are actually available online in this web browser. And so there's definitely it's worth some time to go and figure out how to do it. Like for some instances, like 123D Catch for scanning on your phone works really well. But if you want to do something with actual resolution, no, that's atrocious. But for like if I want to scan a Pringles can, that's fine. But like if I want to do like dental models where I have to be accurate down to like, I think it's plus or minus 50 microns, then I need a real scanner and I need to go and scan it correctly. And so, but they're all very application specific. Like sometimes I've spent like hours designing a very particular thing in SolidWorks or in Rhino just because there wasn't any other way to do it. And then the next day someone will be like, hey, did you see that like In Topology came out last night? Or like 2 weeks ago, and it does whatever you just spent 4 days doing in 30 seconds. And so there's definitely some, keep an eye out on the different softwares that come out.